So, good evening, everyone. So, this is a video session, video recording for the session that was held on 26 January 2024. So, I'm re-uploading the video, remaking again making the video because there were some issues during the recording. So, this is just for practice purposes for the students who attended the session and who wanted to attend but they missed the session. So, I am Rupesh Kumar, and um, so I think there is some issue with the recording. So yeah, no, it's fine. So yeah, I'm Rupesh Kumar, and today we'll be discussing the problems that were discussed in the session held on 26 Jan. So this is a recording for the Friday session from 6 to 8 p.m. So this is a problem on the course problem solving through programming in C. So yeah, so let's start with the problem. So the first question says, what type of device is a computer webcam? So we all know what a computer webcam is. A computer webcam is a device that is used to that it takes in the light signals from the environment and converts them signals into digital form and then sends to the computer. Thus, it is an input device. So the correct answer is a computer webcam. So the correct answer is option A. That says a computer webcam is an input device. Right. So let's move on to the next question. So yeah, just one thing. Right. The next question says a set of instructions to be provided to an electronic machine to perform a task is called. So let's see. Let's go ahead through the options and find the answer among them. So the first option is programming. So yeah, programming is the set of instructions provided to an electronic machine such as computer to perform a task. So that is the correct answer. Option A. So let me give some ends on other steps. So programming refers to the set of instructions provided to an electronic machine to perform a task. So other than programming, the option says processing. So processing is simply in processing refers to the um, like processing means doing some operations on data, doing some operations on data. So yeah, processing something like you are doing arithmetic operations or maybe search operations. And then basically computing involves computation over numbers, say numbers or something. So it requires computation. It is associated with the computation such as arithmetic operations. And compiling is basically compile is refers to the process of translating the high level language into a machine language. So yeah, this is what compiling refers to. So these are the options and this is the correct answer. So let's move on to the next question. Which of the following language does the computer understand? So let's see what are the options. So number one option is computer understands only C language. So that's false because computer actually does not understand C language, and because C language is written in like in tokens used from the English language, and machine actually doesn't understand those tokens. So yeah, then it computer understands assembly language, so it's also false. The third option says computer understands only binary language. So yeah, it's true. Computers are built over the binary language system that involves two digits, 0 and 1. They are also known as bits. So computer understands only binary language. So correct option C. Computer understands only binary language. Fine. Let's move on to the next question. Question 4, which says, which of the following is known as the language made up of binary coded instructions? The options are high level, basic, C, and option D, machine. So we in the previous question only we saw that computer understands binary language. So yeah, so this language, this binary coded language is actually known as the machine language. High level language are the programming languages that we write and they use English words for tokens, but machine language uses only binary digits that are 0 and 1. So answer is option D, machine language is made up of binary coded instructions. So let's go to the next question. Question number 5. So what is an algorithm? The question asks, what is an algorithm? So the options are a process or set of rules to be followed in calculations or other problem solving operations, especially by humans. So no, that's not true. Even the machine can use the steps provided, or set of rules that are provided and perform some operations. So yeah, it's not especially used especially by humans. A process or set of rules to be followed to solve numerical problems only? No, that's not true. It is not restricted to the numerical problems only. A process of set of rules to be followed in calculations or other problem solving operations, especially by computer. A process or set of rules to be followed to solve logical problems only. So no, the correct answer is option C. Answer is option C. Algorithm is a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. So this is answer question problem 5. The next question says, a 2D diagram to represent the steps to be followed to solve a problem is known as. So the answer is flowchart. So the answer is option A. Flowchart is a diagram that represents the steps to be followed to solve a problem. So let me give you some ideas on a flowchart, how a flowchart diagram looks like. So whenever we specify some algorithms, there are some stages in those algorithms. So the most important, the initial first stage is start. So whenever an algorithm is specified, we specify the start point of the algorithm. And flowchart, and for start, flowchart uses circle to denote the start of an algorithm. Okay. And the next step is, so if you want to do or some read or write operations, then we use oblong. So oblong is used to denote read or write operations. Then all the computations are defined in rectangle boxes. And lastly, condition decision. So the decision making statements, all the decision making statements are specified in diamond boxes. So these are the basic constructs that are used for drawing a flowchart, and we will see in later in this session how to use them. Hello, hello, am I audible? Yeah. So let's move on to the next question. Which of the following statement is the most appropriate? So the options are: A, pseudocode is basically a diagrammatic representation of an algorithm. Uh, Whereas in flowchart, normal English language is translated into the programming languages to be worked on. Flowchart is a so it's incorrect statement because pseudo code actually is written in normal English language, and flowchart is a diagrammatic representation as we saw in the previous problem itself. The second question says, second option says, flowchart is a diagrammatic representation of the algorithm. Pseudo code is just another name of an algorithm. So that's not true because we can't. Pseudocode is simply written in plain English to for our understanding purposes. The third option says pseudocode is another name of programming, where flowchart is a diagrammatic representation of the language. Uh, so flowchart is actually a diagrammatic representation, but pseudocode is not the name for programming. So yeah, it's also incorrect. So the option D says flowchart is basically a diagrammatic representation of an algorithm, whereas in pseudocode, normal English language is translated into the programming languages to work out. So option D is correct. So the answer is option D. Flowchart is basically a diagrammatic representation of the algorithm, and pseudocode involves translation of English language into the programming languages. Fine. So great. So let's move on to the next question. The question is based on a flow chart. So I hope you all have seen flowchart, understood the flowchart in the first week itself. So we can see the basic constructs that are used to define this flowchart. So let's go through one of the boxes and then we will start understanding solving this problem. So you can see start of the algorithm is specified using a circle. Then arrows are specified to show that data transfer direction. And then we can see a read and written in an oblong box. So basically what it is doing, it is doing in an input operation. So that's why we are using oblong boxes here. Then we are doing some assignment in the rectangular boxes here. So we are assigning values to the variables I and X. Then there is a condition decision box, that is a diamond box. So in this we are checking whether if I is greater than n. If it is greater than n, then we are doing another operation. We are increasing the value of I by 1, and again we are increasing the value of x by x into I. If the decision is false, just we are simply going ahead and printing the value and then using the circle to stop the evaluation. And in case of the if loop, yes loop, in yes case, we are simply going back to the initial state and repeating the operations again until it becomes greater than equals to 1. So this is how the flowchart looks like. Let's start solving this problem. So let's see what's happening. So let's start with the problem. So initially we are given n equals to 6, x equals to 1, and I equals to 1. So let's start. So we start the input n equals to 6. Now I equals to 1 and x equals to 1. And that we go to the decision box where we check whether if I is greater than equals to n. So let's see, I equals to 1 and n equals to 6. So I is not greater than equals to 1. So it says no. So we move on to the path that shows no. And it directs towards the print statement that is printing the value of x at that stage. And that was 1. So the correct option is option C. See, great. So this is how we are solving this flowchart related problems. So say we wanted to solve this problem like we had how would we get a different value of x? Say I was initialized to 6, then what would happen? Then this decision would be return true. Then what would happen here? I would get the value of 6. 6 is greater than equal to 6. So yes, we increase the value by 1. So I become 7. And then x becomes 7 into 1, that is 7. But you can see that this loop would never end because n is 6 and we are actually increasing the value of I by 1 every time in every. So that would result in an infinite loop in this algorithm. So yeah, so let's go to the next question. It asks, what will the output of the algorithm given below? So let's see again how the flow diagram goes like. So basically we start, then we read the numbers x equals to 5. So we are basically reading 5. So we are reading some values. So x equals to 5. And then we are assigning the value of y to x. Now here y has not been initialized first. So thus this program will result in compilation error. So the correct answer for this will be answer D. So it throws a compilation error since y has not been declared before being used. Fine. Let's move on to the next question. The section of the CPU that selects, interprets, and sees the execution of program instructions is known as. So let's see, let's go through the options. So yeah, let's go to the options. The first option says memory. So no, memory is present for reading and writing data. So it essentially contains memory refers to the faster storage unit provided present in the computers. Memory is directly accessed by the CPU for performing operations, for processing data, and then the register unit is the fastest form of memory that is present in a computer. Then control unit is responsible for determining the execution steps. So yeah, the correct answer is option C. And arithmetic logic unit is especially used, specifically designed for doing arithmetic operations. So correct option is option C. Control unit is responsible for execution of instructions in a particular order. So the correct answer is option C. So these were some basic questions that I took from the previous year's course. And after this, we will be proceeding with some advanced questions on creating flow charts. So we will see how to suppose we are given a problem, how to solve those problems algorithmically, and then converting that algorithm into a flow chart. So maybe we will start in a minute or two. So the problem is something like this. Create a program to compute the volume of a sphere. Use the formula V equals to 4 by 3 pi r cube, where pi is equals to 3.1416 approximately. The r is the radius of the sphere, and we have to display the result. So display the results means simply print the volume of the sphere onto the screen. So this is the first problem in which we will be writing some logic algorithmically that will do the operation, and then we will draw a flowchart on the basis of that logic. Yeah. So let's go ahead and start. First, let's write down the algorithm, how the steps of the flowchart would look like. So initially what the variables that, so whenever we start the algorithm, then what variables do we need? So we know that the value of pi is 3.1416. and we read r, so that is the radius of this of the sphere. Then we store the result in a variable, say v, whose value is given by 4 divided by 3 multiplied by pi multiplied by r into r into r. So this will be the result that we want to return to the user. So let's go ahead and create a flowchart for this problem. So yeah, so we'll first use the start block. So it says start, and then we will. So the next step is creating, defining few values. So basically, we define the value of pi. So we'll use the rectangle box for that, and we will define the value of pi equals to 3.14156. So I guess this was the value that we decided earlier also. 3.1416. Sorry. So 3.1416, and then we will show the data transfer. So we start our algorithm, and then we define the value of pi. Fine. So now we have to read the value of the radius of the sphere. So for reading read write operations, we know that we use the oblong. So do we have the oblong here? Hmm. So I guess we can use the rounded rectangle for symbolizing oblong. So yeah, it is an oblong symbol. So now it works. Yeah. So now we will read in the value of the radius. So we will take a variable r. So we will read the value of r. The input will be taken from the user. Now we need to do some arithmetic operations on the taken the value radius and to compute the final volume of the sphere. So we take in b equals to divided by 3 multiplied by pi multiplied by r into r into r. So this is the flowchart that will give you the radius of a sphere, that will give the volume of a sphere with its with the radius given as r. So finally, we will end our algorithm with the end block. So yeah, this is the flowchart that will result in the that will give us the radius of a volume of a sphere whose radius is given. So let's go ahead and import it our uh, in our solution page. So insert. So this is the flowchart that will take in the read. So sorry, there's a mistake in this flowchart. We haven't printed the value of volume. So we also need one additional step where we print the value of V. So let us go ahead and create another output box. So since we are printing the value, we are performing some operation. So we'll use the operation block here, and we will simply go ahead and print V. So let's finish the diagram connectors, and we are done. Fine. So this is how we draw a flow chart that takes in the input. It takes in input is as the radius of a sphere and computes its volume and prints it on the screen. So sphere. So let's go ahead and import our answer here. So yeah, there is a start, and then we define the value of pi, then read in the value of radius and compute the volume, and then print the volume value and end the algorithm. So let's go to the next question. So it says write a program. So let me do some formatting. It says write a program that converts the input Celsius degree, the input temperature in degree Celsius into its equivalent Fahrenheit in degree Fahrenheit. So basically, and we have the formula for conversion: F equals to 9/5 C plus 32. So how our algorithm will look like? So basically, it goes like this. So we start our algorithm, then we read the value of temperature T in degree Celsius here. When we Celsius, yeah, and then we perform the operation to compute the degree value in degree Fahrenheit. So basically, compute temperature. So let's say we call the variable output y equals to 9/5 into T plus 32 degree degrees Fahrenheit. Fine. Then we print the value of y, and then we end our algorithm. So this is how this problem would look like. Yeah, let me have a check here. Fine. So let's go ahead and draw the diagram for this also. So again, we will start our program using a circle. Start. Then what we have to do, we have to read in the value of temperature in degrees Celsius. So we will use the oblong block here. and read in the value of T, that is the temperature in degrees Celsius. The next step is to convert the value, do the arithmetic operation to convert this value into degree Fahrenheit. So basically, we will use the formula y equals to 9 divided by 5 into T plus 32. So this will give us the value in degree Fahrenheit. Finally, we will be printing this value. So we will use the oblong block here. Print y and yeah. So after this, we will end our program using end block. So sorry, there will be no oblong. So since we are printing the value, we are not writing anything. We will use the computation box here. So basically, we will use this block again, and we will print the value of y, and finally we will end our program. So this is how the program to print the temperature, take in the temperature in degrees Celsius and print it in degree Fahrenheit looks like. So let's go ahead and import our answer. Degree to Fahrenheit. Yeah. So this is how the flowchart would look like for a program that takes in input the temperature in degrees Celsius and prints the degree Fahrenheit. So let's move on to the next question. So the next question says write a program that takes inches into its equivalent centimeters, takes an input in inches and converts it into equivalent centimeters, and it says take note that 1 inch is equivalent to 2.5 centimeters. So let's start writing the algorithm for this problem. So we start and then we read the value of centimeters in x. So length in centimeters. Then we compute y equals to, oh, sorry, we are reading x in inches, and we are computing y equals to 2.54 into x. That will be the length in centimeters, and then print y, and then we end our algorithm. So this is how the algorithm would look like. So let's go ahead and draw the diagram for this also. So again, we will start using the start block. So it's a circle. So we start our problem, and then we will do some read operation. So basically, we'll read in the value of x. So that is length in centimeter in inches. So we'll draw the flow. We will show that data is flowing from the start block to the read block. And then we will do the arithmetic computation. We will simply convert the value from the inches to centimeters. So we do y equals to x multiplied by 4. So the variable y now contains the value in centimeters. We will show the data transfer from this block to this block. So in this block, the input is variable y, x, and the output is variable y. And finally, we will print the value of the variable y. So we simply print y. So after getting the value of variable y, the program simply prints its value, and then we will end the algorithm. So we have to end it, and yeah, it's done. This is how the flow chart will look like for converting length from inches to centimeters. So let's go ahead and import this answer in our program. So it's basically inches to centimeters. Let's import our answer. So yeah, here goes the answer. This device. Let's go to inches to centimeters. I guess there is some issue in saving the file. So we'll simply select this. And then file, and then I will export as PNG. Selection only. Transfer environment. So let's again go ahead and import our answer. So this is how the flowchart would look like for a program that takes in the length in inches and computes its equivalent length in centimeters and prints it. Fine. So let's put it on a new page. Fine. The next question is design a program to find the circumference of a circle. Use the formula 2 pi r. So we are in this problem, we are given the length of the radius of a circle, and we have to compute the circumference of the circle, and we have to print the value of the circumference of the circle. So let's go ahead and write solve this problem again. So our algorithm starts, then we read in the value of radius r, and then we define the value of pi, define pi equals to 3.1416. Then we compute circumference C equals to 2 divided by pi into r, then print the value of C, and then our algorithm ends. So this is how the program looks like. For that, takes in the radius of a circle, computes its circumference, and then prints the value of the circumference. So let's go ahead and draw the diagram for this problem. So we'll use the start block. So it's basically a circle, and then we start. Then the next is the oblong block that reads in the value of the radius. So basically we use the symbol r. So we will simply read the value in the radius variable r. So we show the arrow, shows data transfer from the block S to the read block. So from the start block to the read block. And then we define the value of variable pi, 3.1416. So basically pi equals to 3.1416. So we can use the data transfer arrows that shows that data is going from the read block to the block computation block that is defined the value of pi. The next step is to compute the value of the circumference of the circle. So basically, we again reuse the computation block and compute c equals to 2 multiplied by pi into r, and we use the data transfer arrows from this block to this block. And finally, we print the value of circumference, and then the program ends. So simply print C. And then we end our program using the circle. And so this is how the flowchart looks like for a program that reads the radius of a circle as input, computes its circumference, and prints the value of the circumference. So let's go ahead and import our answer into our sheet. And then I will export. So this is how the flowchart would look like for a program that reads in the radius of a circle and prints the circumference of that circle. So let's go ahead and solve the next problem. So the next problem says we have, so let me clear this up a bit. So the next problem is a bit complex problem. So till now, what we have done is we have solved some basic problems using simpler formulas like computing the volume of a sphere or computing the circumference of a circle. Till now, we have not designed an algorithm in which we were solving problems that requires conditional blocks, so decision blocks. So this problem will help us will explain how we will using conditions in our algorithms in our problems. So for that, the problem is quite big, so it will take a bit of time. So let's start. So the problem says we have a list containing 10 numbers. We want to check whether the numbers in the list are greater than 10 or not. If the numbers are greater than 10, we print yes. If it's not, then we print no. And so the input given to us is the list L that contains the 10 numbers. So it's already given. We are not reading those values from the program. So it is initialized. And we have to go through the all the elements of L and then check whether it is greater than 10 or not. So how to access the elements, the numbers stored in the list. So we will be using use index notation to do so, to access the elements of a list. So suppose our list is denoted by L, then so if the list is denoted by the symbol L, then the elements of the list can be accessed using the index notation, that using indices that go from 1 to the number of elements in the list. Fine. So this is how we will be accessing the elements in the list. So yeah, fine. So L at 1 equals to 1 for the example given us. So let us say L is equal to, let's say let us say that the list is given by this. So basically L equals to this, then L at 1 equals to 1, L at 2 equals to 2, L at 3 equals to 9, and so on. So maybe dot dot dot, and then L at maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I mean, 10, we need 10 numbers. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah. So you have 10 numbers. So L at 10 corresponds to the value 1. Fine. So this is how the list elements can be accessed. So what we have to do. So the algorithm is the program steps for solving the problem goes like this. So basically we start and then start with L defined trigger. Then we check if so repeat until, so we define the value of I to the iterator that will help us, the index that will help us to go through the list. So we define I equals to 1, repeat until I is less than equals to 10. So the less than equals to operator is equal to the mathematical less than equals to operator that we use. So we in that so the less than equal to operator looks like this in programming languages. So make sure you understand this. So it means while it will repeat until I is equals to 10, not greater than 10. So yeah. So what we have to do, we have to basically check if L at is L at I is greater than 10, then print yes, else print no. Then what we have to do, we have to update the value of I so that we are able to access the next element, I plus 1. Finally, our program exits and we end the program. So let's see how we will be solving this problem using flowchart. So let's start. So we will start using the start block again. So we will use the circle to denote the start of our algorithm. So we'll start. Then we are given L. So basically define L. So it's basically a list containing the 10 elements. Then we will go ahead and so the first thing is we have to define an iterator, the index I, that will tell us which index we want to access right now at the particular time. So basically we will start with 1. So we need to give the value of I. So we will declare a variable I with the value 1. So now we'll use the arrow to show that the program is going from this block to this block. And then we will so now what we have to do, we have to basically go through each and every element of the list L and check if it's greater than 10 or not. So for that, what we will do, we need to make sure that we are not accessing any element that's not in the list. That is, the index value I should not be greater than 10. It should be between the values 1 and 10. So there are two steps that will help us to go through the list. The first one is simply the first one is basically getting the value of I, the initializing value of I, and then increasing it one by one and incrementing it one by n through the iterations, and then stopping the iteration when I reaches the value of 10. So this is how this loop will go on. So we will use a conditional block that checks whether I is less than 10 or not. If it's not, then we need to use it. So check if I is less than equals to 10. So if it says yes, then we can proceed with our proceed with checking the elements in the list L. So yeah, so this is the decision block that we were talking about initially in code problem number 6, I guess. So so this is the thing that we are talking about. So we are solving this problem. And the next step is simply go ahead and check the element value in the list I at the index I. So let's go in the list L at the index I. So just check if L at I is greater than 10. If it is, then we have to do something. Otherwise, we have to skip. So let's go here. So let's go here. If it's yes, so maybe we can use a text box here. Yeah. So we get. So if the condition is true, then do this. If the condition is false, so let's say it says no, I is not greater not less than equals to 10. Then what we have to do, we have to basically stop the loop. We have to stop the iteration. We don't need to access any more number of elements. So if it's no, then the program should exit. So we can use the end stop block here. So simply we have to exit from the program. So we'll end the program here. If it says yes, then we have to go ahead and check if IL is greater than 10. It again results in two possibilities, yes and no. So the element at the index I can be greater than 10. It can be less than 10. So again, we will, if it's greater than 10, what we have to do, we know what we have to do. We have to simply print the value of yes. So we have to simply print yes. And if the value of L is not greater than 10, then we have to print no. So basically we use this block. Print no. And then after this step, what we have to do, we have to increase the value of I so that the iteration can proceed. So in either of the cases, we have to do one more operation that will simply increase the value of I equals to I plus 1. So in this step, we are basically incrementing the value of I of the iterator so that we can uh, so that we can go to access the next elements in the list. So we can simply after both the result in same output. So basically same, the outputs are different, but the next blocks is same for both the operations. So basically, so yeah. After this, what we have to do, we have to again go to the if condition where we are checking the condition where we are checking the value of I to be less than 10 or not. So basically, we can like, so I think a better way would be putting it here. So yeah, this is how the flowchart would look like. Hmm. So this is if the value of I is less than 10, so iterator is still in the list range of the values that the list contains. Then we proceed, check if L is greater than 10. If it's greater than, print yes, and we increment the iterator. If it's not greater than 10, we simply print no, and then again we increment the iterator. And finally, what we do, we simply go ahead and check after incrementing the value of the iterator, we check if we again check if whether I is greater than 10 equals less than equals to 10 or not. If it's not, if it's less than 10, we again go ahead, check the value of L at I. If it's greater than 10, print yes, else print no, again increment the iterator. We repeat this step until and unless I is less than equals to 10. If I becomes 11, then it will print no, and we will exit the program. So this is how the program for printing the program that that takes in the input in a list L containing some certain 10 elements, and prints the value of the print the value yes if the content of the element L is greater than 10, else it prints no. So let's go ahead and import this output. So let's go ahead and import our answer here. So through this example, we saw that how we can like use iterators and how we can iterate through the elements in a list. So see, our list was this 1, 2, 9, 22, 100, 90, 45, 13, 6, 1. What would be the output? Outputs. So what would be the output for this? So the output would be no, then no, okay, no, since 9 is less than 10. And then 22 is greater than 10, so the output will be yes. Then 100 is greater than 10, the output would be yes. And then 90 is also greater than 10, output would be yes. 45 is also greater than 10, output would be yes. Then 13 is greater than 10, output would be yes. And 6 and 1 are less than 10, so outputs will be no and no. So this is how our program will work, and these will be the outputs. So no, 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 yes, 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 yes. So no, 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 yes, 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 yes. 5 years, and then 2 again. So this is how the program will work, and this is the flowchart for this particular program. Fine. So let's go ahead. So this is how we. This is a quite complicated problem where we were involved with loops and two conditions here. So let's go ahead and solve another problem, and it's a classical problem used in programming languages and for beginner courses. So basically, we have to write a program that exchanges the value of two variables x and y. The output must be the value of a that swaps the value of two variables x and y. The output must be something like this, that the value of variable y will become the value of variable x, and vice versa. So let's start with this problem. So yeah, so let us say we are given the values of the variables x and y as x equals to 10 and y equals to 20. The program should output x equals to 20 and y equals to 10. So let's see how it works. So let's start designing the solution for this problem. So what our program would do is, yeah. So what our program would require. So we will read in the well. So we will start the problem solution, and then we will read x and y from the user. Then we need to swap the values stored in the variables x and y. So we'll be using a third variable temp. So we will first what we will do, we'll store the value of x into the variable temp. Then what we will do, we will assign the value of y into the variable x. So in this way, the value of x has been stored in another variable, and we are simply overwriting the value of y into the variable x. Then what we will do, we will simply we need to put in the value of the value that variable x was containing at the beginning, that is stored in the variable temp. So we will simply assign the value of temp to the variable y, and we will print the value of x and y, and then we will exit. So let's see how this program works. So say x equals to, so let's x equals to 10 and y equals to 20. So the first step says, right, take a variable temp and store the value of x, that is 10. Then what we do, we assign the value of x to the variable y to variable x, that is 10. Variable of y into the variable x. So x equals, that becomes 20. Then finally what we do, we assign the value of variable temp into value y. So we see y becomes 10. So here we can see we have successfully swapped the values between two variables x and y using a third variable. So let's go and draw the flow diagram for this. So yeah, again we will use the start block, that is a circle, as the starting of our program. And then what we have to do, we have to read into values x and y. So we'll use the oblong for this. Read x and read y. A bit short and select 3. Yeah. So now we have got the value of the variables x and y. Now what we will do, we will define a third variable temp and assign the value of the variable x into the variable temp. So temp equals to x. So this is the variable temp equals to x. Now what we need to do, we simply need to assign the value of y to the variable x. So x equals to y. And then we assign the stored value of x that was stored in the variable temp to the variable y. And finally, we print the values of the variable x and variable y. This we can see that this operation requires some logic for doing the swapping between the variables. So print x and print y. So this is somewhat simpler problem than the previous one, but it requires some logic to swap the values. So we will again now we will go ahead and see how uh, how we basically can how can we do this swap operation without using the third temporary variable. So let's see how that can be done. So this is the answer for our problem. So we basically start, then read the value of variable x and the variable y. We define a new variable temp and store the value stored in the variable x into the temp variable temp, and then we assign the value stored in variable y into the variable x. Finally, what we have to do, we have to assign a value that was stored in variable x initially. So that value is we have saved in the additional variable temp. So we will simply use the value stored in the variable temp and assign it to the variable y, and so finally we will print those values. So this is the answer, and we let us export our output and yeah. Swap values using third variable. So let's go ahead and import our answer. So yeah, this is the answer for this problem. So now say we want to solve the same problem, but without using a third variable. So let's say there is, let's write up another question. Write, draw. So let's start with another problem. Draw a flow chart that takes user input, takes the values of two variables x and y, and swaps their values without using any third variable. So let us see how we can solve this problem. In the previous problem, we saw that we used the variable temp for doing this operation, but now we don't have the liberty to use uh, any other variable. So let's see how we can solve this problem. So let's start. So let's say again the inputs are variable x, and say x equals to 10, y equals to 20. And now we want output should be look like y equals to 10 and x equals to 20. We cannot use any other variable than any variable other than x and y. So let's see how we will solve this problem. So the logic goes like this. So we start our program and we define the values. We take input, read basically the values of x and y, and then what we do. So here are the steps. So pay attention to this, how we are doing this. So we simply assign the value of x plus y to the variable x. So now initially x was containing the value 2, here it 10. Now here what will happen? It will contain the value of 20, that is equal to the sum of both the numbers. And then what we do, we simply so now x contains x plus y. Then what we can do, we can simply take in the value of x plus y that is stored in x. So basically y becomes x minus y. So what happens here is here x contains, so let's say and call these values to be x in it and y in it. Great. then x, the value of x becomes x in it plus y in it. Now we give assign the value of x minus y to the variable y. So here basically y equals to x minus y, and that is equals to x in it minus y in it. So kindly note that x in it and y in it are not any extra new variables here. These are just the values that were currently initially given to the variables x and y. And I have used them just to help you out to understand the logic of the program. So don't consider them as extra variables. They are just the values. So x in it is 10 and y in it is 20. So I can say there's 10 and 20 also, but for the sake of generalization, like for general problems, I am calling these values as x in it and y in it. So basically we assign the value of x plus y to the variable x plus y. So it is basically equals to x in it plus y in it. Then we assign the value of x minus y to the variable y. So this x is currently holding x in it plus y in it, and we subtract the value of y, which was y was holding the value of y in it. That is equals to x in it. So here we can see y gets the value of the value that was assigned to x initially. So this is what we want. We want to swap the values. So finally, what we need to do, y contains the value that was stored in x, and x still contains the value of some of the initial values that were given to x and y. So basically, we simply use x and subtract the value that x was containing initially. So let's see how it goes like. So x is still containing the value of x in it plus y in it, and we subtract the value of current value of y, that is x in it. So this is equals to y in it. So here we can see we have successfully swapped the values between x and y without using a third variable. Obviously, we are using we are using the arithmetic plus and addition and subtraction operations here, but we have successfully done the operation where we are swapping those values. So finally, what we can do, we can print x, comma, y, and end our program. So let's see how this problem goes numerically. So initially, x equals to 10, y equals to 20, then x equals to, after the first step, x equals to x plus y, that is equals to 30. Now y equals to x minus y, that is equals to 30 minus 20, which is equals to 10. Finally, x equals to x minus y, which is equals to x is still containing 30 minus y is containing 10, which is equals to 20. So yeah, so we have we can see now finally x equals to 20 and y equals to 10. So we have successfully swapped their values without using any third variable. So this was the aim of our program. So yeah, we have devised an algorithm that does this task. So let's go ahead and draw the flowchart for the same. So let's start the problem. And then we read in the values of the variables x and y. Read x and then read y. Fine. And then, so these are the user inputs. Then what we need to do, we need to assign the sum of these values to the variable x so that we can start the swap process. So x equals to x plus y. And we use these arrows to show the data flow. Now what we need to do, we need to compute the value of y, that should be equals to x minus y. So y equals to x minus y here. And finally, what we need to define, give the value, define the value of variable x again. So it's equals to x minus y. So yeah, this is how we get the swapped values, and finally we simply print these values. So we can use the print block here. So print x and then print y. So this is the flowchart that basically takes reads two user inputs in the variables x and y and prints swaps their values without using any third variable and prints their swapped values. Yeah, fine. So this is the how the flowchart would look like. So let's go ahead and import the answer in our sheet. So swap without third variable. Yeah, finally we will upload the answer in our sheet. So this is how the program looks like. So basically we start the program, read the values x and y, assign some values to x and y variables. So basically we assign the sum of the two values to the variable x, and then we come extract the value of x and store it into the variable y by subtracting the value from the sum of value of y from the sum. And then we simply get again we get the value of x that should be the initial value of y by subtracting y from that sum. And finally we print these values and end our program. So this was how we solve the problem where we draw a flowchart that takes the value of two variables x and y, swaps their value without using any third variable. So during the sessions, there were some questions that were asked by the students in the chat box. So I will take those questions right now. So the first question is, what is the difference between equals to operator and double equals to operator in C? These are basically so equals to operator refers to the equals to is the equals to operator. It is used for assignment purpose in C. So basically, if we say a variable x equals to 10, this means we are telling the compiler that the variable x has been assigned the value of 10. So this is equals to is the equals to operator. It's not so it is not same as the equals operator in mathematics. That basically in mathematics equals refers to the comparator operator that checks whether the two values are equal or not. So this is not the same as the equals operator in mathematics. And the second thing is double equals to operator. It is the comparison operator. This is an operator. So it checks whether the operands it checks whether the operands have same value or same values or not. So basically, if we say 10 equals to 10, it says returns yes. So here the operands are 10. So operands are defined like this. So basically, I can just put in here operand 1 equals to operand 2. So it checks whether the operand 1 and operand 2 have the same values or not. So if the statement so the output of 10 equals to 10 returns yes. Yeah, so this is a comparator operator in C. So the next question that was asked in the class session, during the session, tutorial session was this: what is the bitwise AND operator? So bitwise operators are defined in C that perform bit level tasks. So they do their operations on the bits 0 and 1. So yeah, so they do their operations on the bits 0 and 1. So the AND operator is basically does the following operation. It checks if both the bits. So bitwise operators work between two bits. The input is two bits. So bit 1 and bit 2. And let's draw a diagram for them. Bit 1 and so let's say two bits. Two bits. We take in two bits are as input. Say A and B. So let's say the bits are A, B, then what would be the output? So if both the bits are 0, then the output is 0. So bitwise AND operator simply returns 0 if both the bits are out 0. If both the bits are, one of the bits is 1 and the other bit is 0, then also the output is 0. If one, again, same happens for the reverse order also. So if the bit A is 0 and the bit B is 1, then also the output is 0. And if both the bits are 1, then the output of the AND operator is 1. So this is what the bitwise AND operator in C. So basically it returns 1 on if and only if both the bits or the inputs are on. So they are set given the value of 1. It's false even if returns 0 if any one of the bits are off, that is 0. So let's say so apart from the AND operator, there is another operator, bitwise OR operator. So let's see what it does. It also takes in two variables, two bits A and B as inputs. And let's see what are the outputs. So if A is 0 and B is 0, it simply returns 0. Again, similar to the case for AND operator, but it changes for the second case where the one of the bits is 1. Then it returns 1 basically. And then if the same is for the reverse order also. And if both the bits are all 1, then also it returns 1. So bitwise AND operator is used to check conditions where we want to say and. So some condition and the other condition is also true. If the bit A and the bit B both are containing value 1, then only return 1, otherwise return 0. The bitwise OR operator says if either of the bits if is 1, just return 1. So either bit A is 1 or bit B is 1 or both of the bits are 1, then return 1. So this is these are some of the bitwise operators that you will be surely learning in the course lectures also. So this was a problem that was raised during the tutorial session itself. So the next question is, what is the radix? So radix is the base of a number system. So system, it refers to the number, the total number of digits used to define a number system. So one of the most commonly used is decimal number system. Decimal number system uses bits, uses digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The total number of digits the total number of digits in decimal number system is 10. So its radix is 10. So similarly, for binary system, we use 2 digits. These are 0 and 1. So the radix is 2 for binary system. So apart from this, there are other systems such as octal that uses 8 digits. Then there is hexa. So you will learn about this in the future lecture. So this is what a radix symbolizes. So radix is basically the number of digits used to define the number system. So yeah, this was the first tutorial session that I took on 26 January 2024. So in case you missed out this session or you had some doubts from the session, I will share this video and this answer sheet with you guys. You can go ahead and read it and see the video again. And you can also reach out to me for in case you have any doubts. In the future sessions, I will be taking these sessions every week, every Friday from 6 to 8 p.m. So I'm Rupesh Kumar, and I hope you enjoyed this session. So that's it from my side. So yeah, so we'll end this session. Maybe I can take a few minutes, maybe 1 or 2 minutes, to go through the few of the basic problems again. So just for revision process for this session. So basically, what was the output for this algorithm? This was returning a compilation error because y was not defined before it was being used. Then one of the most complex problem. So maybe I can revise few of the things from this session. So initially we started with some of the problems that were taken from the previous year's courses, and we saw some of the basic definitions that define a programming language. So, and then we saw what is a flow chart and and a pseudocode looks like. Then we solved some problems on the flow charts. Finally, we started with the problems on drawing flow charts from scratch. So we defined some programs to solve some problems, and we draw the flow charts for them. The first problem was computing the volume of a sphere from a given radius. Then we used draw the flow chart to compute the temperature in degree Fahrenheit from a given input in degrees Celsius. Then we draw a flow chart. We draw on a flow chart that converts length in inches to its equivalent centimeters. Again, we solved a program that requires us that asks us to take in input the radius of a circle and return its circumference. Finally, one of the most complex problem that we solved was that uses decision blocks was that we are given a list containing 10 elements and we want to print yes or no based on the value of those elements. So basically it required two elements. If first one was the iterator for iterating to the elements of the list, and then we were checking if the list value was greater than 10 or not. If it was greater than 10, we were printing yes. If it was not, we were printing no. And then the iterator was going on. So this is the output look like for the example given. Finally, the last problem that we did on the last two problems that we did using flowcharts was swapping the values of two variables. In the first problem, we were allowed to use any other extra variable, so we used the variable temp for the swap process. In the second one, what we were it was constrained on the number of variables that we can use. We can't use any extra third variable. So for that, we devised the logic through which we were able to accomplish this. And finally, I give an idea on the equals to and the double equals to operator in C language, about the bitwise and bitwise OR operators, and finally, what is a radix in C language. So that's it for this session. Thank you all.